nonpolar. So there's 3 things that we're doing with each of these, and we want to make sure that we get all 3 things for each of them so that we get all of the points possible. So I'm going to underline the 3 main parts, and we'll just make sure at the end that we've got them all. So part 1 is looking at BF3 and PCl3. We'll do each of them individually. When I'm doing Lewis structures, I want to look at how many valence electrons each of the things have and gives to our sharing of electrons. So boron is in the 3rd column on the periodic table, or 13 depending on what periodic table you look at, which means it has 3 valence electrons. It has 3 electrons in the 2 energy level, which is its highest energy level. Fluorine has 7 total, and those 7, there's 3 of the fluorine, so we're going to have 7 times 3, and at the end I'm going to want to do a check for the total number of electrons, which is going to be 7 times 3, that's 21, plus 3, 21 plus 3 is 24. So in the end, I want to make sure that I have 24 electrons. Boron is slightly different than most of the ones we deal with because it only needs 6 valence electrons to be stable at the end, and that is because it's such a small molecule, it really can't fit a whole lot else around it. So I'm going to start drawing things out. My fluorines go on each of them, and each fluorine comes with 7 electrons, one of which is shared in the shared bond here. Same for this one. And the same for this final one. Now the octet rule is satisfied with all of my fluorines because there's 2 electrons, plus 2, that's 4, plus 2, that's 6, plus 2, that's 8, around each of the fluorines. Again, boron is odd, it doesn't need 8, it just needs 6, which it does. It has 2, 4, 6. Then I want to do this double check of 24 at the end. So I have 8, 10, 12, 14, 16, 18, 20, 22, 24. So sure enough, I do meet my total, so that part is good. The shape of this, I see that I have 1, 2, 3 electron clouds. 3 electron clouds, which means I have a trigonal planar shape. And then whenever I have a trigonal planar shape, I am non-polar. So I've taken care of all 3 sections of the question for part 1. Now I need to look at the PCl3. I'm going to start out the same way by doing a little bit of accounting. So phosphorus, it is element 15, and it has 5 valence electrons. The chlorine is in the same group as fluorine, it's just down 1 more energy level, and it has the same number of valence electrons, 7. Again, there's 3 of them, so 7 times 3, for a total number of electrons, 21 plus 5, that's 26. So I'm going to look for that at the very end. I'm going to put the one that needs the most in the center, so phosphorus. It has 5 electrons, 1, 2, 3, 4, 5. My chlorines each have 7, so I'm going to put a chlorine off on each side. And I can make a single bond between each of the phosphoruses and chlorines, so they're sharing 2 electrons each. Now I want to do my double check. Do each have 8 electrons? So I'm going to look at each one individually. Looking at this chlorine first, I have 2, 4, 6, 8, so that's good. Looking just at the phosphorus, I have 2, 4, 6, 8, so that's good. This chlorine, 2, 4, 6, 8, that's good. And this one, 2, 4, 6, 8, is good as well. So that all fits. Now I need to see if I have my 26 electrons total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So sure enough, I have 8 around each and 26 total. So now I can move on to my second part of the problem, which is to identify the shape. And I have 1, 2, 3, 4 electron clouds, and only 3 of them are bonds, which means I have trigonal pyramid. Because of this unbonded pair of electrons there, I am absolutely going to be polar. We're going to do the same thing with part 2, So2 and Co2. I'm going to do that on a new slide. So starting out with SO2. I again need to look at the periodic table to see how many valence electrons there are. Sulfur has 6 valence electrons. Oxygen also has 6 valence electrons, and there are 2 of them. So 6 times 2 is 12, plus another 6 gets me to 18 total. So that's going to be my check in the end. And the one that I have the least of, since it's the same number of electrons, I can't put the one that needs the most because they all need the most. I'll put the one that I have the least of in the center. So I'm going to put a sulfur there, and it has 6 valence electrons. So 1, 2, 3, 4, 5, 6. Okay. I'm going to put an oxygen on either side of it. And if you don't see it right away, you can always start out with single bonds between each species. So I have single bond, single bond. I want to see if my oxygens are satisfied. So it has 2, 4, 6, 7. Oh, that's not good. The sulfur, though, 2, 4, 6, 8 is good. And let's look at this oxygen, 2, 4, 6, 7. That's no good. So something's going to have to change here. This is one of those where the electrons can move a little bit more than we're used to. We're going to see that we're going to have one double bond. So what will happen, we can erase those 2 there, erase that. One of my electrons from this bond down here that I erased is going to bond with the one that was over here. So now my sulfur has 2, 4, 6, 8, and the oxygen has 2, 4, 6, 8. Well, that other electron that I erased from down here is going to jump over to the oxygen. So now this oxygen has 2, 4, 6, 8. Well, let's see if it matches my total. See if I did this in an okay manner. So we need 18 total. 2, 4, 6, 8, 10, 12, 14, 16, 18. Sure enough, I have 18. So this is a good stable compound. You might ask if the double bond could be on the other oxygen. Absolutely it could. It's going to be the same either way. Now, I have 1, 2, 3 electron clouds. 2 are bonds, which means I have a bent or a V-shaped. Anytime I have bent or V-shaped, or again because I have those extra unpaired electrons there, this is going to be polar. Okay, one final one to look at. We have CO2 now. Carbon has 4 valence electrons. Oxygen we just determined was 6. There are 2 oxygens again, so 6 times 2, that's 12, plus another 4. We're looking for 16 total electrons this time. The carbon needs the most number of electrons to be satisfied, so we'll put it in the middle. 1, 2, 3, 4 valence electrons. The oxygen has 6. 1, 2, 3, 4, 5, 6. This oxygen, same thing. 1, 2, 3, 4, 5, and 6. I'm going to start out with single bonds again. You can probably anticipate this isn't going to be satisfied this way, and we can see it right off the bat. The carbon only has 6 electrons around it. Each of the oxygens, just like last time, only have 7. So what I'm going to have to do is shimmy around my electrons a bit. I'm going to get rid of the ones that I drew on the end here, and also get rid of where I put the electrons around the carbon. I'm going to share those in bonds. So the one that was up here is going to go down here and be shared with the one that was over here originally. And the same thing over here, the one that was down there is getting shared with the one that was there. So now carbon has 8, oxygen has 8, oxygen has 8. Let's see if I have a total of 16. I have 2, 4, 6, 8, 12, 14, 2, 4, 6, 8, 10, 12, 14, 16, excuse me, and absolutely I have 16 total. I have 2 electron clouds, both of which are bonds, which means I have a linear shape. Linear shapes are always going to be nonpolar.